See math. Okay, so at the top, okay guys, listen up. This is going to be, obviously that's 4, so plus 1. That's going to be a negative 7 plus 1, and negative 2 plus 1. We're at 3 points so far. You're working in red pen, please. Then use a different color. Just don't use pencil. That's fine. Okay. So we're at, it's right there. Okay. Ready? Graphing. It's y equals mx plus b. My b, my y-intercept is positive 1. My slope is negative 1/3. That should immediately tell me, since it's negative, my line should go this way from left to right. So, this is worth 4 points. Please don't immediately mark stuff wrong. There's going to be partial credit. If they have a dot at positive 1 on the y-axis, that alone is plus 1. Okay, now, my rise 1, my run is 3. So I don't worry about the negative. All I worry is about which way it tilts. I can go up 1 and over 3 this way, down 1 or over 3 this way. Either way works. No, it isn't, because it's negative. It's negative. That's why, guys, you get in your head. That's why I don't want you to, oh, it's negative 1, I go up or I go down. Don't worry about that. If it's a negative line, it's going to go down from left to right. You ready, guys? Go, put your arm up like this. Put your left arm up like this. Ready? Trace, say slope up.
Slope up.
Positive.
Positive.
Okay, now go down. Say slope down.
Slope down.
It's negative.
Negative.
Okay, that's all you have to worry about. Okay? Yes, ma'am. Let me get the partials going now. Okay? All right. Now, this is the only thing that gets plus 4. Okay? Now, partial credit. If they have the dot where it belongs properly, that's plus 1. If they just tilted it the wrong way, but if you count out, that is going to be 1 over 3. If they have this black line, you may give them plus 2 overall. Okay, if they tilted it the wrong way, but it still goes through the 1, and the tilt is 1 over 3rd. The black line. You see the black line? Okay, let me give you another variation. What if they tilted it correctly, but they went through this positive along the x-axis? You may give them plus 2 for that. All right, any other variation I've not covered? Yes, ma'am.
If it goes up 1, and then up 3, and then up 1.
Is it negative? So it's like that, and does it go through 1?
Yeah.
Okay, so it's like this, 1, 3, and over 1, like that?
Yes.
In other words, that's a 3 and a 1 instead of 1 and 3. Is that what you're saying? Does it go through this one right there?
Yeah.
Okay, plus 2, but then show them how to count it correctly, okay? All right, at the bottom, I say solve for x. You're going to get 1 point for the work, 2 points for the answer. I know 25 plus 10x minus 5 plus 90 equals 180. Then you collect like terms. Excuse me. Okay, so I have 10x plus, I add these up, I get 110 equals 180. 10x equals 70, x equals 7. What's worth credit? Work plus 1, answer plus 2. Okay? I just said solve for x. Okay. Score out of 10 and return. It's out of 10. It's out of 10. It's out of 10. It's out of 10. Score out of 10 and return.
The last one, 3 points.
Yes, ma'am.
Oh, you got a 9.
Oh, wait, if you got a girlfriend. What did you get an 8 out of 10?
That's a problem.
An obtuse isosceles that describes the same. Obtuse is greater than 90, isosceles, two equal sides. So an obtuse isosceles triangle like so. Now you have to start combining descriptors. An obtuse isosceles triangle looks like so. Okay, look, if you don't know what the word scaling, that's what the green spiral is for. Look at the green spiral. I want you to draw an acute scaling. Go, you have 15 seconds.
Where do we write it?
Right underneath. If you don't know what the word scaling, look at the green spiral, please. Alrighty, guys, take a look up here. Acute, all angles less than how much? Out loud?
90.
Less than 90. Scaling, no equal sides. So you should have a triangle where it's obvious that they are less than 90. And how do I show unequal? One, double, triple. My tick marks don't match. That's what it is. Nothing matches. That shows it's scaling. Either that, or I could actually put measures there. I could call that 7 centimeters, 8 centimeters, and whatever, 10 centimeters. I'm just randomly pulling numbers out of a hat here. Okay? All right. If you have a couple colors, get them out. A couple colors, get them out. Doesn't matter. Well, I'm going to ask you to turn them off real quick again. You'll live. Okay, ready? Now, draw two triangles right here, please. Two triangles. Two little baby triangles, please. I don't care where. Two baby triangles. Okay, yes, looks like a jack-o'-lantern. So just put a 180 in the middle here. That stands for that your triangles add up to 180. That's the real simple concept that was in last night. Now I'd like you to take one side of the triangle, stretch it out, and sweep. That's called an exterior angle. Yeah, I would do that in a different color. That's why I switched colors. Sweep, stretch out one side and sweep that exterior angle in a different color. Okay, what was also in last night's video is the exterior angle always equals to the sum of what is called the opposite interior angle. So it's away from, but inside. So these two angles, the two blue angles, add up to that exterior angle. That's called the exterior angle theorem. That was on the videos last night. I would use two different colors there. Okay, now I'm going to do two problems with you, and then you're going to be on your own. I'm going to be consistent with my colors. Okay, ready? So in this one, be consistent with your colors, whatever you use. This is an exterior angle. Sweep it in whatever color you used. That exterior angle equals the sum of these two interior angles together. Put a little plus sign there. Notice I switched colors so it matches. So now let's solve for everything that we can solve for. That means 110 goes over here. 5x plus 11 plus 8x plus 8 goes over there. I'll pause and let you catch up. I'm recording, by the way. Okay, now we collect like terms. I underline my x's and I double underline my numbers. So I have there 5x and 8x, 13x, plus 19. You solve for x from there. If you would need a calculator, you may use it, although you should be able to manage without one. Plug it in. Plug it in. Plug it in. Plug it in.
What?
All right. Take a look up here, guys. You should have gotten x equals 7. When you plug it in, 5 times 7 plus 11, 46. 8 times 7 plus 8, that's 56, is 56 plus 8 is 64. Watch what happens. If you add 46 and 64, oh, surprise, surprise. Yeah, see, it actually, what's really nice is you can check your work with these, and you know whether or not you're correct. Let's do another one together. Yes, ma'am?
Could you just divide 110 by 2? That's easier.
No, because you don't know they're equal. You don't. If you knew they were equal, yes, but you don't know they're equal. Yes, Ilbert? Yes, over there. All right, let's do another one. Ready? Sweep this exterior angle. Notice I'm keeping my colors consistent. My exterior is in red. 7x minus 4 equals my remote ends plus 55. Your exterior angle equals the opposite inside angle. The two angles on the far side of the triangle. Add them up, solve for x. So it's called the opposite interior, which means there. Okay, so here's the triangle. These are called the opposite interior. Why? 1, they're inside. 2, they're across. Some textbooks call it the remote interior. Okay, collect like terms. I like to double underline my variable and single underline my numbers. You're solving for x. Now, do not get all happy once you solve for x. What should you do with x? Plug it in, plug it in. Yes, so 2 times 12 plus 1. This is 25. That's 55. Now check. Do a check. 25 plus 55. Yes. Catherine asked a really important question. Do you have to do a check? The answer is, do you want to be right?
Fine, Jim.
Yes, you do a check.
If you don't check it like on a test, it's wrong.
I will mark it down. I will tell you to check it, yes.
Why would you not? I don't know. It's just
On a test, I will force you to check it.
Okay.
Alrighty, guys. When you're done with that, turn the page. Okay, this is your ambition, guys. Let me type out, look at the clock, because I'm actually going to give you a timeline what you should be working with. Okay? So, you want to work on page 3, finish and check by no later, let's see, 11, about, let's say 11:45. Okay, finish page 3. Then you're going to do pages 4 and 5, finish and check by 12 noon, no later than. If you're done, if you're ahead of the game, you just keep powering through. Then you're going to do page 6, finish and check page 6 by 12:05. That should only take you 5 minutes, page 6. Then you're going to do pages 7 and 8. That's going to be a hands-on lab. That's the tennis ball lab. When you get to that, raise your hand. I'll be happy to help you. Okay, that's your timeline. All right, yeah, go ahead and turn the light on. Okay, please don't mark anything down until I tell you what the partial credit is. Step number 1, this is 60. That means this is 120. Look up here, guys. We're really short of time. We're just going to make it. If this is 3x plus 2, this is 3x plus 2. This, of course, is just 3 plus 2x. So I'm going to go 3x plus 2 plus 120 plus 3 plus 2x equals 180. Collect like terms. Okay, there's more than one way to do this. Don't panic. Give me a second. Okay? All right, so collect like terms. I have 5x. This is plus 125 equals 180. Subtract. I have 5x equals 60, 55. 55. X equals 11. You're not done. Plug it in. 2 times 11 is 22 plus 3. That is 25. Yes, that's 3 times 33 plus 5. This is 35. This is 35. That is 120. Do I tell you to find everything? Solve for x. Find the measure of all angles in the diagram. If they found x plus 2, if they found all the rest of the angles plus 1, score and return.
Wait, they forgot one. What if they just got X?
Okay, it's plus 2 if all they did was find x. I said find all the angles. So plus 2. Okay, turn it in. Back left tray. Back left tray. Back left tray. Where?
Oh, we want to do video.
I need to find out what happened. Okay. You go late. I you go late. Are you guys? Do you have a game on campus? No. You should go. Your coach cannot get out. He's going 2 minutes late. Yeah, back left tray, guys.